Hi guys, Monday, week third out of the 15. So time is moving fast. Um, Today, there's another video of me, and we're gonna do what we usually do. I'm gonna give you some feedback um, on your assignments. I'm gonna remind you what you have to submit until Sunday midnight, and I'm gonna cover what we have for today, which is chapter 4 and chapter 5. All right, so I'm gonna go ahead and share my screen. All right, here we are. I hope you can see it. So for next week, we have LO4, okay? And also we have LO5. So two LOs, no synchronous meeting, okay? And today we're covering exciting stuff, per usual. How are we gonna do a lit search? And some very basic stuff about the study design, how we design our studies, which again, all these have to do with your final learning opportunity. And again, those are the fundamentals. We're going to go into more detail as we move forward with our next chapters from our textbook. So concerning LO3 and LO4, I have my notes right here, right? So the LO2, I guess that was what I was trying to say. So LO2, the average score it's 83%, and for LO3, the average score is 86%. Now, I don't. What I see as a pattern is I see lower scores when you are rushing it. So when I can tell how much time you're spending for each submission, and I can tell that there's distinct pattern of or association, right, or correlation. I'm going to talk about that today between time spent and final score. What I'm trying to say is take your time, spend a little bit some time to study the material, and go to our book. So, for example, for LO2, although there were no items that the majority of you missed, there are a couple of items I want to make a comment. So there was an item that was talking about which feature is not does not belong in EBP, and the answer is in table 2-2. If you go there, you'll find it. Okay, so the fact that a lot of you missed this item is an indication that you're not studying the material a lot. So pay attention, okay? Study the material. Everything is in our book. And there's another one about that has to do pretty much with the definition of practice-based research. And the answer is on page 26. So if you miss that item, which pretty much defines practice-based research, go to page 26. The answer is there. If you still have questions, let me know, okay? Then about LO3, there was a question about the pilot data demonstrating to an agency, right, that you have the ability to collect the data that you're actually proposing that you're going to collect. So, and that answer for that is at the very end of chapter 3, page 47. So you'll see how pilot data can be used in terms of grant proposal submission, okay? So those are the two comments I have as a general feedback for LO2 and LO3. I would like to see some higher average scores. So please take your time, and hopefully now that you're going to do it for the third time for this week 3, you know more what to expect and how much time you have to invest, right? Okay. So I hope you got the message. I'm going to stop sharing this, and I'm going to start sharing LO, the PowerPoint slideshow for chapter 4. Okay, 2 chapters for today, chapters 4 and chapter 5. I want to also remind you, I'm going to try to say that at the end of this video, that tomorrow, again, we have office hours from 8 to 12:30, right? I'm going to include a link in that email that I'm including this link, and no synchronous meeting this week, right? Okay, let's go here. We need chapter 4. Is it this one? Yes. All right. Let's see if this works. Okay, cool. So 2 chapters today. And as I said before, these are going to be important for your final learning opportunity. Before I even start this chapter, I want to say that we have a whole, I have a whole PDF in that FLO folder that has to do that has to do with how you do a lit review, okay, or review of the literature. So that is fundamental in figuring out your research question and your hypothesis. Okay, there's a whole guide over there. We're going to talk about a lot of this today as well. Cool. All right. So again, we start with this, which is the process. And today, what we're going to go about is this, right? Talk a little bit about how we're searching in the very beginning in the body of language, in the body of knowledge concerning. We're looking for answers, so we're trying to see what is out there. Okay, so that's what we're going to do today. These are terms that I want you to know by the end of this chapter. And again, in our book, you've noticed there's a glossary at the very end. All right, so when we talk about scientific literature, right, we're not talking about any kind of literature, right? We're not talking about creative literature. So these are specific examples of what you should consider as scientific literature. Abstracts, books, conference proceedings, which is when you go and submit, for example, an abstract for your research at a conference, and it gets accepted, and that conference publishes their findings. So there's a special, usually, journal that comes out, if they do it through a journal, a specific volume that is called conference proceeding and includes everything that was presented in that conference. Okay, we're going to talk about review and meta-analysis in a little bit, and then of course original research, which is when you are producing something new. So when we look into the literature of what is interesting, important for you, we'll start by looking in everything. Okay. All right. So in order to do that, we can search in certain databases. We talked a little bit about databases. Okay. And a very first way to group them is between free and paid. So we have those public ones, and I'm sure you know Google Scholar, right? I'm going to talk about a little bit more about Google Scholar in a little bit, and PubMed. So those two are free, which means you don't have to pay. Okay, so we can do our search for free. The private ones are specific databases that you can look into there unless, for example, our university, our library, we are paying some kind of fee and they allow us to use that database, which is pretty expected. Of course, not all universities pay fees for all databases. They pick the ones that are more important for them, cheaper sometimes, And then on the right side, in that column over there, you see private databases that are very specific. Okay, so Embase has medical articles mainly, right? And Cochrane has has to do with rehabilitation, physical therapy, stuff like that. So sometimes we look into databases because we know that that's most likely where we're going to find what we're looking for if we're looking for something specific, right? So that's one way to differentiate databases. Now, literature. We talked about what is scientific literature. Let's talk about types of it. One way to do it is primary and secondary. I'm not going to say, and nobody's going to say that primary is better than secondary or the other way around. They're different, and they can help us in different ways based on what we're looking for. On the left side, you see the primary is something that shows something new. So original research, scientific paper, conference papers, reports, thesis, dissertations are presenting some new findings. And that's why it's called primary. Secondary, it does not present anything new. However, it combines information and we get that aggregate info. That's why I have the reviews and meta-analysis of the textbooks. So a textbook is great, but it's considered secondary. Okay, it has information from several authors. So on the right side, you see a type of research which is really important, especially for us. For example, for our FLO, we can find a lot of information at just one specific point. So you get a review or meta-analysis and you get so much information about the topic that you are interested in, right? Because somebody else went and did the lit review and wrote a paper about it, right? So they give you a lot of aggregated info. So that's the basic, a basic way to group scientific literature. Primary, new findings. Secondary, not new findings, but aggregated info. Okay? All right. So PubMed and Google Scholar. Let's talk a little bit about the online. Most of the search is happening on Google Scholar. So once it came out, it just dominated. And the good thing when compared to PubMed is when you put the same keywords, you get a ton of results, way more than PubMed. However, it doesn't mean that they're all relevant. So there's a debate about the quality of the results you get back, right? Definitely you get more with Google Scholar. PubMed will probably give you more specific, more like closer to what you're looking for on average. So for PubMed, as you can see, there are big names behind it, NLM and NIH. Those are the ones that are supporting this database. And we're talking about a lot of research, right? And as you can see, the records it says here are indexed with MESH, right? The method of subject research. So it's a little bit different, the descriptors that we're using here. You'll see, we'll talk about that in a little bit. And that really affects the way we are searching the database when compared to Google Scholar. As I said, Google Scholar has dominated, most of research happens there, but what the results we're getting back are a lot, but the relevance is not always there for what we're looking for. Okay. All right, we talked about, let's talk about PubMed. I already talked about MESH, and it's a different way to put that research into categories and how the way we are can look for it. PubMed also has the spell check that gives you suggestions. Once you put your keywords, it can give you suggestions for alternative spellings, so you can find similar papers, right? It has also related citations, so when you find some articles, it can give you similar articles, so you can expand it. But also has a lot of filters that you can use and narrow your search. Of course, if you have never used PubMed, It'll take you a little bit to get used to it, but the more you use it, the easier it's going to get. Okay. Uh, in general, I've already mentioned the term keywords. We need to put some keywords in that search engine, right? In order to get back some results. Those keywords sometimes are called descriptors or identifiers or search terms. Same thing. Okay. Now, in general, you should start your research with some broad topic, right? And then little by little, you're gonna be more specific. So, but don't be afraid to start broad. Now, you can search for the past 5 years. Right, that's called a limiter. So you can say, I'm only looking for reviews. You can say, I'm only looking for those specific authors. So that helps you get back less results that are more specific to what you're looking for. Another cool thing is the Boolean operators. So the Boolean operators are some words like and or that we usually put in capital letters. So if I want to look for mental toughness and research that has to do with mental toughness, but only has to do with sport, I can write mental toughness and all capital sport. So it will give me whatever has both, right? Also, I can use quotation. And if I put mental toughness in quotation, I'm looking for those two words in that specific order. Mental toughness, right? So I can put mental toughness in sport or athlete. So it will give me all the results for mental toughness in sport or mental toughness in athlete. So we can play with all these things. Wildcard symbols, we're talking about the exclamation mark. For example, the exclamation mark that will give us that it can replace an unknown character. So if you put an exclamation mark in a word, that will give you all different combinations of that word with wherever you put the exclamation mark. There is an example in our book, right? It will give you all the different alternatives of that word. And there are other symbols for giving you alternative spellings and so on and so forth. When we talk about proximity, we usually use N or W, and again, there are examples in our book. So with N and W, we can identify if we want these words to be, for example, mention the first word with the second word that we have in maximum 3 words in between, right? So it's proximal, like it's close to it. And if we care about specific order or non-specific order. So you'll see all these examples in our book. Not in all honesty, not everybody's using all these symbols, right? However, if you know how to use them and if you know what you're looking for, they can really give you higher quality reports when you get the results back. So you don't have to go through a lot of articles, for example, that they're not whatever you've been looking for. So all these are ways to expand or limit your search. But in both cases, there are ways to give you back more relevant results. Okay. Now you can find literature in other places as well. So you can try to find relevant studies. As you can see, you can search in other databases for unpublished data. You can try to find specific experts or manufacturers. You can go to ACSM and see what you can find in the ACSM website. You can use the citation searching that it says here, which is, for example, you can see who has cited a paper that you found important, that's called forward citation. Or you can go backward citation, which is usually you see the reference list of that paper that you really liked, and it's really right there for whatever you're looking for, and see the papers they've cited. That's backward citation. There is literature that's unpublished out there, right? So you can look for that. Of course, I'm going now in real depth, and it's not that everybody's going there, right? Nobody's looking. Not nobody. Most of the people don't go that deep to find the information they're looking for. However, we need to cover all this. Okay. Now, can we use Google, for example? Sure. However, we have to understand that we are looking for scientific evidence. So we need to be very careful. And of course, a lot of research engines have their own apps. So you can search through your mobile smartphones. Some apps give you the whole thing. Some apps give you just the abstract. It really depends. But there are a lot of different ways to look into the literature. But these here are the main ways to do it. Okay, especially if you're looking for free. All right. Now, you found a lot of research. What are you going to do with it? You have to evaluate the quality. Even if something looks very close to what you're looking for, it doesn't mean that you should use it. You have to evaluate the quality of that piece of work, right? So is it peer reviewed? That really increases the quality of whatever you find. And then you go over everything and you see, do you really want to include that? Does this come from a reputable journal, right? Or does it give you enough information to justify tomorrow to reviewers why you used it or why you didn't use it? Okay, so we need really to go into depth and figure out the quality as well. Of course, in the beginning, we'll get the quantity. We'll just take out the ones that are not good for what we're looking for. But then based on what we found, it doesn't mean that we're going to use all of it. Okay, we just need to justify what we use and what we don't. Now, that makes me remember about my dissertation, my PhD dissertation, where you find like tons and tons of research, and then you find the abstracts that you like, and then some abstracts you can find them in the library, so you request them, and they keep coming, and you save all these PDFs, and you create files on your computer, and you try to figure out what's going on. But there are reference software that can help you, right? And when I was a PhD student, I bought EndNote. That's something I have to pay a fee. There are other ones that are free. Some from the library of our university, right? Or each university. It really depends. But they can help you put in there the PDFs and then start doing some kind of grouping based on your inclusion and exclusion criteria. But it's really hard. It's really a challenging process to not only understand what you're looking for, find it, and then you actually have to store all that information in a way that you remember why you thought this was important, and you have to write down everything as you go, because when you go back, you have to remember why you searched the way you searched and why you included the things that you included and you excluded the things you excluded, right? So it's a process. It takes time. Yeah, so that's for chapter 4. I'm gonna stop sharing and I'm gonna talk about chapter 5. And this will help us a little bit understand more about our FLO as well. All right. I'm gonna start this chapter by saying to you something that my mentor used to say, which is not his quote, right? It's coming from the 90s and from group of Harvard professors that they wrote a book, which you can find on Amazon if you want to. The lead author is Richard Light, and it's a book about designing study design. And my mentor used to tell me when I was trying to figure out how I'm going to do my research for my PhD, for my dissertation, that you can't fix by analysis what you bungled by design. So this is very important. Let me say it again. You can't fix by analysis what you bungled by design. So design is really going to determine how we're going to move forward. And if we make a lot of crucial mistakes right now, no matter what kind of analysis we'll do later, maybe we can't save it, right? So figuring out the study design is really, really pretty much the cornerstone of the whole thing. And me, let me be honest with you, sometimes I'm a reviewer. No, I'm a reviewer. Sometimes I review articles and I have to reject them because the way they design their study, there's no way to fix it. There's no way to fix it. Usually we reject a paper, a manuscript, when there's no way for them to address whatever weaknesses we see. And if you have messed up the design and you pretty much cannot answer the research question because of the way you design your own project, research project, then, it's inevitable. So this is very important, right? And this, again, will help you with your research design for your FLO, all right? Okay, let's start. Again, we're here. Now we are at this part. Okay, we're designing our study. A lot of terminology. We're going to go over all this in a little bit. And again, these are terms you should know at the end of this chapter. Okay. All right. We have already covered the scientific method, and so far it's the best we have. Okay. So here, again, it's the same thing. You're thinking about your FLO, right? You're thinking about any project. What do you want? What do you want to investigate? And in this specific step, which is the very first step, you shouldn't be intimidated. So you can think wide. You can think outside the box. You can ask those difficult questions, whatever. So just be very blunt with what you're going to look for. It doesn't matter how it's going to end up. In the very beginning, you can go big. You should go big, actually. Okay? Now, after that, narrow it down. Okay? Find a more specific problem that happens right now and something that you can actually tackle based on your time, your resources. Time is a resource, based on the availability of your resources, for example. Okay? And then, what is your hypothesis? As you know, as you understand the literature, right? What is your hypothesis? What's your research question? What are you trying to solve? And we're going to talk a lot about variables today, but what are those variables that you think are involved in answering your questions? Okay? And you see what's out there, right? You identify the gap. And as it says here, single study can't fill all the gaps. So you need, I would say, to narrow that question. So you're narrowing the gaps, or so you know what you're trying to fill, right? And then at the very end, you need to think, who cares? I love that question, right? That was from another mentor of mine. So that question is huge, and I use it all the time. Who cares? Who would care about the results, the possible results, the outcomes, the expected outcomes of this research project, and why, and how could they use them, right? So all these are important questions to ask as you're going through this approach that is based on the scientific method. All right. Variables. What can be identified as a variable? a lot. Pretty much you see from gender and weight all the way to their environmental conditions, right? And the dosage of the drug, everything. So for us in the health field, you need to understand that whatever you're looking for, that specific thing, right? That's one variable, and it can be examined next to other variables, or it can be affected by other variables. And all these variables have to be written down, identified, so you know what you are looking for, what you're against. That. All right, let's break it a little bit down, right? Okay, so what? How can we categorize them? The very first thing you should do, and we all do, is to understand if we are talking about an independent or dependent variable, right? The the thing that you're usually looking at, right? You have to understand what's your outcome variable. What are you actually looking for, right? What are you looking for? That's on one side. And on the other side is what is going to change, what affects this that you're looking for, right? The temperature, the weight, the height, the dosage, the whatever. So anything that can explain a change here of this variable that you're actually looking for. They can be free fat mass. Right, you're looking at that, and then you're looking for like diet, sleep, resistance training, exercise, cardiorespiratory exercise, any kind of variables, gender, age, training age, all kinds of variables. So you have to write down whatever you think is affecting that one thing that you're looking for. If you're looking for one thing, who knows? So you have to pretty much put them on one side or the other. Are they your response variable or their explanatory? Dependent or independent, output or predictor. Right? Those are the same names for these kind of variables. Right? Think about what's your output variable. A lot of times in statistics we'll call it dependent because it depends on these, right? Which are called independent. Okay, so that's one way to understand things. Create two columns. You put here your output variable, and you put here the variables that can predict changes in this one that you're looking for. Okay, that's very basic. Another way to do it is, are we talking about quantitative or categorical variables? So categorical variables, as you see, like gender, race, level of experience, or level of risk for cardiorespiratory event or whatever, they're categories. They're not numbers, right? So sex, for example, is male, female, right? Race is race, right? Level of exposure, like, are you a novice or you're an expert? Do you have a low level of risk of cardiorespiratory event, of cardiac event, I'm sorry, or high, or medium? Those are categories, right? Are you Division 1, Division 2, or Division 3? What are you? A student athlete, right? Are you professional? Are you semi-professional? That's the level of competition, for example, right? And then we have quantitative, where we have numbers. It makes sense. We can quantify them. Are you 6? Are you 6'2"? Are you 5'8"? Are you 100 pounds? Are you 200 pounds? Right? Is your 1RM 100 pounds or 200 pounds? Can you run in 5 minutes 1 mile or 1.2 miles? Okay, so that's one other way to identify variables. Why is that important? For many reasons, especially when you try to understand what you're looking for and how are you going to do the analysis later on, okay? Now, subcategories. All right, don't freak out. We'll go one by one. Nominal all these are categorical. Nominal are, for example, gender, sex, race, right? No, there's no order. Okay, it's not that Asian Pacific comes before African American, which comes before mixed. No, there's no order. Doesn't mean the order doesn't give us any information at all, right? What we need to do is what we need to know are the categories. Okay, ordinal now we need to know the categories, but also we need to know the level, because here, if you are between, there's a big difference between non-professional and professional. There's a big difference between expert and novice. Right? So we need to know the ranking. So the difference is there, and there's a specific ranking of those categories. Interval. So interval and ratio are another way to think about them. Interval, you have the categories, you have the level of rank, but there is that uniform spacing, but there's no 0 point. And an example is RP, the Borg scale, which is from 6 to 20. There's no 0 in it, right? So here we have the categories. We can have categories based on the RP scale, right? There is a ranking, right? There is a uniform in spacing, 6, 7, 7, 8, 8, 9, 9, 10, right? But there's no 0 point to use as reference. Ratio now are a specific type of interval. And here we have the 0 as a reference point. And an example is the repetition maximum. We can have 1 RM, we can have 5 RM, and also we can have percentages. 60% of your 1 RM, 80% of your 1 RM, right? So all these, why are we mentioning this? Because those are different subcategories of the variables. And if we can identify where these variables go that we just identified, or as a predictor or an outcome variable, right? It helps us understand definitely how we're going to analyze the data, and if what we are gathering actually answers our question, and in what way. Research question. All right. Extraneous variables. Also, you can see called confounding or intervening. If I am looking for the free fat mass, and I am using an intervention, a specific, like a heat training, and I'm trying to see how it's going to affect any changes in the free fat mass. So free fat mass would be my outcome variable, dependent. And independent would be that heat protocol that we just thought about, and we want to test it as an intervention. Which other factors would affect free fat mass? A lot. From age, sleep patterns, diet, so on and so forth. If we don't take them into consideration, if we don't control for them, then can we really say that whatever difference we saw on this side comes just from the heat training intervention protocol? No. So a lot of times you'll see in research that, yeah, we do the intervention, but we try to control, to tell them how much sleep they're going to get. What are they eating? Or at least, if we don't, they tell them to write it down. So then we figure out the calories, and then when we do the statistical analysis, we control for those extraneous variables. Those extraneous variables can really affect what's happening here. So we control for them in the analysis. We just take them out in a way to see the net effect of this on this, right? Because in life, there's no just one variable that affects another. There's a million variables that can affect the outcome variable that we just thought to investigate. All right, so be careful about the extraneous variables. You need to identify them and find a way to account for them. All right, types of research. Let's start with descriptive. Descriptive are great. Descriptive are awesome, and descriptive is giving us a lot of information. Is it the best? No. Is there the best type of research? No. There's some better than others, but that's about it. Every type of research is important, and every type of research is valuable based on what you're looking for. Okay, so let's start with case studies and case reports. Here we have a really low number of participants, maybe even one. And we're investigating something very rare most of the time. So, for example, a case study, if we had a specific type of cancer and we only have like 5 people who had it in the world, right? That'll be a case that is something extremely rare. And it cannot be investigated in large sample sizes because they're not large samples. So in that case, we report something that is really rare, and we need to do it through a case study or a case report. Happens all the time. Now, can we use that for the rest of the population? Okay, we can get some information out of those case studies, but because again, it's not something that is common in the population, so the sample is not representative of the population, we can't really extrapolate. But it gives a lot of important information, for example, in practitioners that have to do with cancer treatment and see what's out there and what's happening, and they will figure out how to use that kind of information. Right? So they have important and specific, we get important and specific benefits. Case series is a case study or a case report, case study, a type of case study that is, we are investigating, we're following that specific case or a specific small group of people over time. Right? That's called case series, and that gives us, again, important information. It's more longitudinal. All right. Correlational studies in general are important, especially in the beginning of investigating something new. They're very, 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 very crucial because based on them, we can start creating hypotheses. And based on them, we can start creating interventional studies later on. Correlational studies, though, they're not giving us, they give us the relationship between 2 or more variables, but the direction or the strength of the relationship, and by direction I mean, let's say we have 2 variables, if one goes up, the other one goes up, that's direction. And the strength of the relationship is usually, let's say, Pearson correlations, right? They go from -1 to 1. 0 means there's no correlation. The closer to 1, there's stronger positive relationship, and the stronger to -1, the stronger a negative correlation, interrelationship. So it can be 0.05 or it can be 0.95. 0.95, whether positive or negative, is a very strong relationship. That has to do with the strength. And again, the direction is positive or negative. If it is positive, if one goes up, the other goes up. If one goes down, the other goes down. If it's negative, one goes up, the other one goes down. Okay? All right. So correlational studies, very important, but they cannot infer causality. What does that mean? So that means that because these 2 things are correlated, it doesn't mean one happens because of the other. And a great example that I can use is that temperature, or not temperature, consumption of ice cream and murder. So it is highly correlated. Those 2 are highly correlated. So when consumption of ice cream is going up, the murder rate is going up. Why? The correlational study doesn't really answer the why. It just says that when the ice cream consumption is going up, murder is going up as well. Is that a fact? Yes, that's a fact. Do they really? Why is this happening? So in order to figure out why this is happening, we have to figure out the why. The why is not part of a correlational study. Correlational study just takes 2 or more variables and see, as we said before, if there's any kind of relationship between them, and more particularly, the direction and the strength. All right. Another cool thing is that we figure out was Facebook users in the economic crisis in Greece. So there is a strong positive correlation between amount of Facebook users in Greece and economic crisis. So somehow there's an interrelationship. But why is this happening? Does this relationship infer causality? No. Is economic crisis happening because the amount of Facebook users has increased? No. Something else is going on, right? Our merger is going up, the number of mergers, because the ICU consumption is going up. No, there's no causality. There's just some kind of relationship. Right? So I just gave you two examples to make you understand that correlational studies did not give us, have nothing to do with causality. Now, cross-sectional study. What is a cross-sectional study? Cross-sectional study is usually the opposite of a longitudinal study. And cross-sectional study is giving us a snapshot of something that's going on. Right? So today, I'm giving you a mental toughness questionnaire. So today, I know your levels of mental toughness. That's pretty much it. If I keep giving you the same questionnaire every 2 weeks from now, for the next 5 years, that wouldn't be a cross-sectional study. What's the major benefit of a cross-sectional study? Well, it gives you information about a specific time, and it's really fast, like right now. But the fact that today is high or low, it doesn't mean that in 2 weeks it will be high or low. It's just a snapshot, and that's it. That's it. It's great to know what's going on today, but it's just for today, right? If I wanted to make a case about your levels in general, I should just do multiple assessments, right? And if it's high for all of them, it's high. If it's low, it's low. Then there's a different kind of analysis, and there's a different kind of inferences on those results that I can make. So cross-sectional is a snapshot, and it's pretty much the opposite of longitudinal design. Ecological studies are longitudinal designs. So I keep investigating something over time. No, I'm sorry. Ecological studies are going to be using bigger samples, right? So here we can have a snapshot of a huge part of the population that has to do with chronic illness and disease. So I have huge sample. I may even have the whole population if I could, right? But again, it's a snapshot. In the ecologic studies, there's a thing. If you try to make some kind of infer causality from a correlational study, even if it's ecologic study, so the sample is huge, we call this ecological fallacy. So it's a classic example of trying to over-interpret the results that we may have. So correlational studies, if they're cross-sectional, ecologic, whatever, they're just now. It happened now, and they don't infer causality. All right? So have case report, case study, and then if it's over time, is case series. Correlational studies give us the direction and the strength of a relationship, but it cannot infer causality. Cross-sectional is a snapshot of a sample. Ecologic studies is a snapshot of a huge sample, even the whole population of whatever we're investigating. All right, observational studies. The observational studies are important, right? And they are, again, in most cases, we cannot infer causality. There is no intervention. We're just observing something that's going on. We are not really intervening, okay? And there are two types. There's a cohort study, and there's a case control study, which there we have most likely at least two groups, okay? Now here we go to the experimental. Experimental, we are looking at the apex of research, which is RCT. And randomized control trials are the best way to do research in order to get the highest quality of results. So in RCTs, we have randomization, which means we place the participants in different groups randomly. And also there's some kind of intervention. There's some kind of experiment going on. Now, in some cases, we don't have the randomization part. So we have the intervention, but we cannot randomize the participants in the groups. And one example is, or we don't have more than one group, right? So in that, we only have, for example, control intervention studies, CIS. And there, for example, that's a common example, I'm sorry, in our field, especially, think about this example. You're trying to see the effect of intervention in your favorite hockey team. And the coach says, okay, let's do this thing and let's see if it works. So we're going to do a measurement before the intervention, pre-intervention, and one measurement after the intervention. Okay. So we have pre and post measurements. However, we can't really persuade the coach, or it's not something that we can do. We cannot split the team into two teams. Be like, okay, this team will do this cool thing, and this other team won't do it. Right? So in that example, we use the whole team. We have an intervention. There is some kind of an experiment, but there's no randomization. There's only one group. Okay, that's an example. A more specific example in RCTs that gives us even more higher quality results is the crossover design. In the crossover design, we have two groups. Let's say one, we do intervention A, and the other we're doing intervention B. We intentionally leave some time. And after a little bit of time, we take those same groups. We've done the pre and post measurements already, but we just switch, and we use intervention A here and intervention B here, and we do the same thing. So we take our measurements again, and the additional thing we get is that the same person can be used as control to their own score. So and it's more ethical sometimes, because if something works, we should offer it to everybody. So the crossover design is even a stronger RCT design in terms of quality of results. Double blind out. I already talked about crossover. I didn't know how to slide about it. My bad. Double blind. Double blind helps with higher quality results because there's less bias. And in this type of study, I don't know as an investigator who is placed in which group, and the participants don't know it either. So for example, I have a new supplement that I want to test, and I have two groups. One of them will take placebo, so I'm just going to give them sugar. Same size of pill, same color, same everything. So they don't know who is in which group. And the other group will take the new supplement. I'm going to put them both in the same kind of regimen, like they're going to do the same resistance training protocol. So you see now I'm controlling for that. So they're doing the same thing. And then at the end, I'm taking some measurements to see what's happening. What I'm trying to say here is that if the researcher and the participant, none of them knows in which group they are, that increases the quality because it decreases the bias. Okay? Systematic review and meta-analysis. Again, this is not original research. It takes a lot of time. And although it doesn't produce something new in the sense that it's not new findings, it is new because it's combined and there's some kind of synthesis, right? And then it comes out with some kind of conclusions about the whole literature, whatever you were trying to review. Now, as you can see, there may be a specific way to do it or not. There's a PRISMA guideline that gives you specific guidelines of how to do a systematic review. And then if you want to move it any further, you can even do meta-analysis. Meta-analysis is about effect sizes. So we standardize the effect sizes of, let's say, different interventions on the same thing that you're looking for. And then we put them all down and we give you aggregated info of what it worked and for how much, right? So it's a code called Prisma guidelines. That's pretty much what most of us use, right? In this specific way, how to do a lit review and a meta-analysis. Again, if you don't want to do the meta-analysis, it's fine. You can definitely do the systematic review and stop there. And there are different kinds of reviews. Like right now, we're doing a mapping review. That's a different kind of review if you don't have a specific question and you don't really want to synthesize, you just report. So you can just do the systematic review. If you want to take it further, as I said, you can do the meta-analysis. It has more stats into it, right? And it has to do, again, with that thing that's called effect size that you have to remember with the meta-analysis. Again, nothing new in kinds of new findings, information is new because somebody or a team of people sit down and trying to figure out what's going on in the whole literature and offer us the aggregated information, okay? Errors. Do we have the perfect design? No. But as I said before, you cannot save a design that has a lot of errors by just doing some cool kind of analysis at the very end, right? Maybe if it's something small, you can figure things out. But if your design is off, like a lot, and it doesn't really answer your research question, you're kind of doomed. So right here, at this stage, we have to be very, very careful, all right? All designs have errors, and all research has errors, and all peer-reviewed papers have limitations. That's why there's a specific area that you can see limitations and delimitations, right? Now, what is our duty? Our duty is to try to minimize those errors, trying to minimize the errors as much as we can, although we do know that there's no way to have zero, okay? Now, what's the difference between random and systematic? Systematic, of course, is something that happens systematically. So if we had a scale that was off, all the weight measurements that we took are off, and that's a systematic error, right? Can we prevent that? Yeah, we can. But also the good thing about systematic error is if we figure it out and it's like pretty much a constant, like the error is the same error, we can fix it easier, right? So if we knew that the scale was off by 2 pounds, we can just fix it if we find that out early enough. Random error is something that we cannot anticipate. Sometimes we figure things out like because of our experience, okay? But random errors are just random. And you can't really anticipate something that is random unless you're experienced enough to know that there's 1 in 100 cases that this may happen. So we need to be very cautious. Okay, right? That comes with experience though. And the errors that we can definitely try to minimize are the systematic ones. All right, I'm gonna stop sharing this. A lot of information for today. I hope you liked it. I hope you learned enough. Please study our book. There's no way for me to cover everything in these videos that are just above an hour, so we're good. Again, I want to remind you that we have 2 LOs for Sunday, which means 2 chapters, right? No synchronous meeting this week, but we do have office hours tomorrow, right? From 8 to 12:30, so log on. If you need something, just let me know. All right, guys, so if I don't see you tomorrow, I'll see you next Monday. All right, in the meantime, live intentionally, not habitually. Okay.